So let us get started. So until yesterday, so we looked at these concepts basically to operate on databases. So remember the constraints that we face while sharing the data and keeping the data in within the code uh, zone itself, in the sense that in the same server, and the relationship between the code and database, how it is separated. And we also looked at a model or an architecture called as MVC. That is something which you need to remember. So MVC is model view controller, and we looked at Postgres SQL. So can there be SQLs, or can there be databases without port and such things? Like yesterday we hosted the database and we tried to connect to the database. Yes, there can be such databases where you may not host it. So one of them is called as SQLite. It is by default installed when you install Python. So it's a similar thing, but all the data that you store will be in a file. So uh, you cannot host it over the network. So in order to do that, you need to use MySQL, Postgres, etc. So each of these are from different companies and from different philosophies. So although they have SQL queries similar to each other, but they're slightly different in terms of syntax and order of um, the columns and the values and so on. But when you're writing code, if you're focusing your programming on um, you know, i- towards the programming, not towards DB admin. So you don't have to remember SQL queries so much, but learn little bit about SQL, like basic statements like select, star, and how to insert, update, such things, so that you can uh, translate them using abstraction layers such as SQL Alchemy. And in Django, Django has its own ORM models. So ORM is nothing but object relational relationship manager or relations manager or something like that. So basically, they are abstraction layer over the SQL. So we looked at that. So you don't need to be expert in SQL, but just be aware that how SQL works and how database works. That is most important thing. And we also generated code, and we stitched into um, our requirements, and then uh, we wrote and read something out of the using pandas. So that's about yesterday's class. And yeah, so we'll proceed with the like project. I'll talk a little bit about like code organization and what are these things. For example, if you look at this, so the source code control has is saying that there are 560 files which are needs to be checked in, or which are now here. Okay, so most of these things are coming from you remember we did a environment creation, Python environment creation, virtual environment creation, and we activated it. And so it has, since it's in the same folder, the Git repository, it is complaining that not complaining, it has detected there are so many changes. But how do you you know tell Git that ignore all of this? So we have a file called as git ignore, right? So if you just do Control P, so you can search the files here. You can tell that, okay, ignore all the environment or something like that. What is the environment name? IEMV, I think. Now you can say that it is auto refreshed, and it says there are 7 changes now. Those 7 changes are like we had created this. So what you means is untracked. It is not a part of the Git. So we were talking about local changes, and then you put it to commit, and then you push it, right? So there are three stages. So these local changes are not uh, part of the Git. So that is why it says untracked. So M means modified. For example, if you look at this, I have modified one single line saying that it is in progress. So in order to, this is my local changes now. It says that this file is modified compared to what I have. And you can simply add it to the commit stage. So you can see that. So those are called as like staged commit, stage changes. So now we have staged it here. You haven't so there is one like temporary step here, staging. So because you can edit a lot of files and you can just move it to staging area. From here, you can actually commit. So this is one temporary area. So now I have also modified git ignore file. I'll check that, put that into staging area, and you can uh, commit. So these files, at the moment, I don't require it. So because those are all temporary files, this too, while demonstrating, we created out now temporary files. So now we can put some message saying some more changes, and then you just commit. This will get into commit, but it is not yet part of the um, the main branch or the main not the remote repository. So this is like your local repository. So that is one of the ideas behind the Git, right? You can have your local changes and your local repositories. What you have. I'll go here and let us look at this, not this one, this. So you can see that the latest changes were 2 days ago, which means it's not yet gone inside this. So how do you do that? You kind of push it periodically. Okay, yes. Now it seems like it is done with pushing it. You can see that the changes got reflected here. So you can look at the commits, and this is how you can see the changes. If you click on this, the latest change, it will show you the difference, what was added, and if it is removed, it will be in red color and so on. So yeah, so that is about like revision about Git. And since you saw we saw a lot of files here, and what are those and how do you escape that? Because you don't want to check in all this environmental files, right? Because you may create, they are not part of your source code. So that is about this. So let us try to rearrange the code in a way that it matches our um, uh, design. Where are those files? Save news here. We did this, but this is just a um, this is direct script. This was sort of an experiment. So put it back to so put it back to the code. So probably we don't require all of this. So if you're unsure, but in production, you shouldn't have these sort of comments, unnecessary comments like the experimental code and such things. And also you shouldn't have print statements. We'll come to that today, why we shouldn't have print statements and what is the alternative and such things. So like if you want to like move the code around, so this moving is typically called as refactoring. Refactoring is nothing but sometimes what happens is you keep writing code and so it's all sort of messed up, and because of delivery pressure, people start mixing up things, and there is no enough time, or there is no guardian who can look at this and say that, okay, stop this. Even if there is chance, we sort of let it go for this time, and we create another item to refactor the code. So generally, that's what happens. So this moving around code is called as refactoring. For example, I can put all of this, say 12 to 21. So this is where it was. I use VI editor. So on top of this, so you can see that I sort of edit multiple lines at the same time. So you can learn that, but it's not mandatory now because so initially, right, in around early 2000s, there were no very good um, IDs like this. So there was, I think, there were something related to Java, I think IntelliJ or something like that, but it was too heavy. And there was also Visual Studio, but it was mostly specific for Windows and things like that. And we didn't have we had development servers which were all based on Linux, and then we didn't have any way to install or have UI sort of a thing those days. So we used to log into Linux systems and then edit the code. And yeah, so everything was done on command line. So one of such editors is VI editor. There are also other editors like Emacs, and I think there is something called as Note or something like that. Yeah. So yeah, you can learn a little bit about. So there would be some places wherein you won't have access or luxury of having this ID on your system. For example, you have deployed something and then you want to modify some configuration file on production system, or something like that. So during such situations, only editor by default available on Linux will be vEditor. So it's a good skill to learn vEditor. Okay, and you can see that there are some error like you know, messages here. So we will talk about that, about code quality and what are the tools around that. So let me just move around things here. So API. Okay. Let me just take this out. You can see that URL, and then so that anything that you that changes, right? Those are variables, but for example, this URLs can change. So make that as uh, we have already made it as variables in the function. So move them, up and make it sort of either part of some configuration or just the global variables like this. And do not hard code anything, especially inside the functions, because hard coding. If you start hard coding, what happens is you are limiting the functionality, right? You cannot reuse it as you want. So that is one of the things that you need to keep in mind while looking at the code, or writing the code or reviewing the code. So if there is something hard coded, make it a variable, move it to somewhere else like header files or global variables, things like that. So we are passing this and this. So this is API. So at this point of time, I do not know that what is the variable. So that should be your goal. So I'm not looking at the variable. And I know the structure. So this is the structure, and return article news, list of articles. So what we need to return is list of news. Or actually just news is just fine because it's not a list. Uh, news. I think so now from that, it's like from garage to the from your POC to the production. It's like, drawing small sketches and then making a painting later. So that is what we are trying to do. So we did some scratchbook work here, and then we are trying to put it in an order. This is like painting. So this is your function now. So now it looks good. So now we need to see whether it works. So let's see if it works. I'll remove all this code. I'll just keep it somewhere safe so that I can refer it sometime if I need. Helps to keep track of what we are doing. So yeah. So now we have got, we have moved the code around and we have got this. So we know that this part of the code works, but whether it works now, let us see. So how do you test it on the same file is generally we can use if name is equal to main. Okay, so this limits the execution when you import it. So for example, if I import news.py somewhere else, um, this code doesn't get called because this if condition doesn't match. So that is the reason we write this. So you can also do this, but what happens is if you um, do this, when you import it, the Python interpreter starts executing the code, right? So you sort of invoke the function instead of just um, importing it. So do not do this. And what should be the variable in passing? What should be the variable that we should be passing here? Is this URL because it is taking API. URL becomes API, and API does some get some response, and let us go to here. So put it here, intend it, and let us see how it works. Yeah, it still works. So there is a print statement here which gives us confidence that the code that we have moved around is working. Okay, so now coming to the one of the important concepts, it's called logging, and why uh, we shouldn't um, write print statements. What are the limitations? So when we use print, so basically print is a function which prints on the monitor. Okay, so all these prints that we have got is just on the monitor. So if this code ever goes to production and these prints, if they are not captured, so how do you run things in production is like there will be some trigger file or trigger point. So say, for example, if you have deployed in on a Linux box, so maybe there is a shell script which calls, say there is a shell script called as news.sh. So within this news.sh, you would be having our uh, Python file getting called. So probably you will have user bin and some Python pointing to that particular complete path. So you can also use just Python, but generally in shell scripts, there could be multiple versions of Python on the same Linux. So you point it to that particular Python, or you create a virtual environment and say that this is the Python you need to use to execute this. So maybe I'll have news.py. So what we have is, so you remember we discussed about how process gets spawned. So when we say sh, so and do this, so there is operating system, and then there is user area or application area where um, you have this terminal at the moment, TTY, and we are invoking sh on that uh, you know file. So it creates um, a shell. Uh, so it creates a shell, and then it uh, starts the process. So that process name is here news.sh. News.sh. Okay. So this is the process name. So when the process gets spawned, you will get a process ID, and parent process ID will be the shell that invokes, and that is PPID, which is parent process ID, and so on. So when you do this, and if you're watching it, you're triggering on the terminal, you have logged in and looking at the terminal, you can see the logs. Okay. But it's not always the case. So we do not manually trigger this file. So there will be some trigger points. Say, for example, it could be a part of service. So you might have heard about Linux services, where you can, when the system boots up, you can uh, you can make it to start using some daemon jobs service, Linux services. So you can also use some commands to uh, instantiate a service. For example, the database that we are running, it was part of some service, Linux service. So when you have services like this, so it doesn't go through that TTY and then shell and OS, because you are never logging into TTY. And what happens to the print statements that we are you know seeing from the bare eyes, right, on the monitor, because there is no monitor in the server. So there is no TTY, you cannot see, and you won't be able to capture it unless you do something like uh, capture that command and put it to a file, say some file called as log.txt or something like that. So um, this is one way of capturing the output, whatever it is producing, to a log file. So there are so one thing is your print statements are inefficient in telling, for example, when was those functions called, like time of the um, that code invocation, and which module invoked it, and there are several other features inside the logging. But so basically, what we want to find out when we look at log files or this sort of logs, right? We want to look at like the sequence of events, event sequence, and then also time. So what happens to event sequence when you have print statements is, so this is just a normal file. So imagine there are multiple within that file within Python. Maybe we are using say multi-process um, sort of a process spawning. So like sub-process, we looked at sub-process. Um, we briefly looked at it. We didn't do anything. So when you want to execute a command within that code flow, you use sub-process and you can spawn. Also, there are libraries where you can create multi-processing sort of an execution. So then you'll have process one, process two, and parent process will be your news.py. And so, okay. So you can spawn those processes. So what happens to this file is that, so whatever is coming out here, it may not be one thing in order, may not be putting here. So it is sort of a black box. We do not know what is happening here. Okay, so all the logs may not be captured in sequence. Probably you are overwriting it. So if somebody has put double the symbol greater than symbol, so it gets appended, not in a sequence. There is so this is not a scalable solution for logging, and it doesn't have multi-threading or multi-processing, where multiple processes or multiple threads are producing the output, and it's trying to put things into the log file. So in such cases, so this is not efficient, right? And if the guy who has deployed, if he has not put this statement, there is no way that you will be able to retrieve the logs, because it has just executed it has printed using print statement, but it has printed in its own shell, and shell gets exited, right? So these are the problems with print statement. So print statements are specifically designed for to see things on monitor. So that is about print. So what are the solutions for this? Like, how do I capture? How do I debug? So most of the time we spend in debugging while dealing with code, right? So what is the best practice to do this? So best practice is to use logs. So what are logs in code is that um, you do not print it into on a terminal. You print it to a file. So when you're printing it, so log libraries or logging design made in such a way that it handles multiprocessing and multi-threading, uh, s- a sort of an design, or it supports them. And what it helps us to do is it makes sure that we almost it is in sequence. So if there is sometimes it may happen that it is out of sequence, but that is still fine, because logging also gives us timestamps. So timestamps can help us to um, uh, um, track when the event had happened, and what is the delay between two functions, when it got started, and so on. So there is timestamp, and then there is logs. And yeah, so how do we so do we need to write our own timestamps and things like that? No, because these things are already like repeated patterns from years of software experience, right? People who have written libraries for this. One of the libraries is called as logging. So this supports quite a lot of features, which we will see right away. So do not use print statements in your code unless you are doing like scratchpad work, like like we did here and we did here. Okay. So this is one of the bad practices. So there are tools when you're checking in the code. There are tools where you can run some tools and say find out some common errors like print statements. It says that okay, you need to remove this, or else I won't allow you to push your coding. So there are tools like that. Okay, so how do we get rid of this? Let us try to understand how this works. So there is a library called as logging import. It is part of your basic installation. You don't have to do pip install. So once you have logging, um, this is just a module, right? So how do you um, uh, like create an object out of it, and how do you work with that? So let us try to understand basic properties of logging related to logging. So let me show some notes and implement it. It's in my repository. You can check it out. It's logging in here. I can get out here from different monitor. Okay. So So we will learn about logging levels, and this is how we do the basic configuration. Let us just take this and try to understand this. Okay. So this is about understanding the concept. So you don't have to remember, like you know that there is logging and when to use what. So let us look at the various levels of logging. So what do you mean by levels of logging is, let us look at our code here, just this small snippet, and try to understand when to use these various levels of logging and how does it help. So why there are different levels. So generally, when you try to print, right? So these statements, this always prints, uh, regardless of you want it or not. So you cannot disable this prints. Okay, you will have to go to each line of code, and then you have to put this hash marks to make it a comment. Okay, so that is one of the disadvantages in print. So now coming to our code, we can identify some parts of the code which we might think that this is, if this happens, it is a fatal error. If this happens, it's a it's a showstopper. So what are such conditions? For example, this URL could be unreachable. So maybe I will have a code here in response part of the code. I may cross check. So here in our code, you can see that there are no validations here. For example, response could be bad. So what happens when the response is bad generally is it just stops, right? So it says that um, there is a exception and it stops executing. So that is why we have try and except block. Okay. So let us try to modify our code according to like with validations. So you have response, and then if this response is not, say, 200, like we looked at response dot status, which is a good status. 200 means it's like okay. So we looked at inspect element and looked at the status codes, right? So if response is not 200, there's something terribly wrong, and I cannot serve the news to the customers. So that error is probably, I think it is a fatal error. So in such case, I may put um, you know I can highlight that error. How do I highlight that error? Is using different levels. So one is there are, so now we have this is one case, like this is like fatal problem. So without this I cannot proceed. So there could be some situations where you just want to see some variables and see the sequence of your code execution. So it is just for information purpose. It doesn't make or break the code. Such things are called as like info logs. So it is just for information. So there could be some places where, for example, if I go to title, maybe I find some junk characters, not junk characters, characters which is not supported at ASCII level. So ASCII has only, say, some Chinese characters or some like European characters like umlaut, something like this. Okay. So in such cases, probably there is uh, maybe I want to parse it further. While parsing, I may get this error, but this is not a fatal error. Maybe it affects the reading, or maybe it's sort of I want to read this out. Probably I want to do something else or some action. So in such cases, you decide that okay, this is not information, but this I need to capture. It's not at two extremes. It's not just information. It is not also fatal. So there are other levels in between those. So you can put it to debug. Okay. So that is how you decide the levels of severity. So these are called as severity of the logs. So let us try to understand. Now we understood the severities and what are the severities supported by this logging library, and how do we um, sort of use it. Okay, let us say, so these are the levels of like logging. So let me, there is warning, error, critical, and so on. I think there is also fatal. I don't know. So you don't have to remember. Yeah, there is also fatal. So there are different levels. So let us take fatal and then say I'll copy this line and go here and put it here. So when does this log, when should this log get logged? Um, Would not get uh, response. Okay. So I will put a condition called as a response. Probably it is status code. Yeah, status code um, is not equal to 100. So now we put a validation around this. So when you so you can see that when you're writing code, we also put this blank lines. So if this is one of the like tips while writing the code, do not put everything in one place. It looks scrambled. It's like looking at a kid's plate where a kid has mixed everything on the plate, right? So it doesn't it's not readable. You cannot sort of parse it well. So when you put these lines while reading the code, it's like a reading a prose or reading a novel or a poetry. So it's like, okay, this is something related to importing, and there is some request happening. Probably I want a line here as well. And you see that, okay, this is part of one block. So you can even put it like this, depending on your taste. And okay, so now you see that, okay, this line is clearly this particular step is validation, this particular step is you're getting some articles and log fatal. Okay, and then you probably want to return false. Okay. At this point, this is how we do the validation. This is most important in the code. It is not just writing the, we jotted down our ideas and we started writing the code. While writing the code, at each step, we have to think what could go wrong and we should handle those errors. So this is where your coding experience comes into picture. You need to start writing the code and imagine what could go wrong. And each of these errors, you need to handle it. So this is called as defensive coding in coding terminology. So because we are validating the input, for example, I could have whether I could have a function which can say validate validate URL, and then I can put it here as well. So if this is true, only then go ahead. If this is not true, return something like this. So this sort of coding. So you can see that the logic is the same, but we are adding more content into this. Okay? So since I have not defined this function, I'll just comment this. Okay. So coming back here, so we are learning about logging. So while learning about logging, we are trying to learn about defensive coding, validation, and all these things. Okay. So because these topics we cannot separate it out and talk about it, because we have as student or as normal human beings, we need to understand, we need to reach a necessity and then we try to understand that. If there is no necessity, then our brain won't consume it. For example, if I just start talking about defensive coding, it's like, okay, it's a concept and it's there in the mind. But when you write code and demonstrate that this is the place you are validating, and this is called as defensive coding, and then you won't forget it. So now we have created a necessity and doing something on top of it. So yeah. So this is how the code grows gradually from your bare minimum skeletal code to something more. And generally put all of this inputs in the beginning of the file. Um, that is just code convention and request this one. Okay. So let us try to simulate this error. Okay. So in fact, to simulate this error, the right way to do it, you create a folder called as tests. Okay. And then you write uh, test, say news.py. And then you remember that we did unit testing, right? So you can actually write unit test cases for this. So let us try to do that. It's quite simple. So because we are not going to remember stuff. So it's like either go to ChatGPT or you can simply go to like Stack Overflow, say unit test, Python example. So sometimes if we do not have access to ChatGPT, so just do this. So this is exactly what ChatGPT also does is it has scraped the internet, the whole internet, and it gives in certain format. Okay. So now take that snippets and take test news module. This is part of this. So this is nothing but inheritance. So we are inheriting test something here. So let us just get rid of all of these test cases. We don't require this because we just wanted that template to write the code, right? So while writing test cases, so in VA editor, what we can like if you do not have access to IDE, right? You can actually you want to see your actual code, which is here, the implementation code and the test code side by side, or it should be visible. Either you have different monitors and drag your terminals around, or else if you do not have, so this IDE provides a feature where you can look at this. You can split it to right, up, down, and so on. So this is what I'm used to, and you can simply, if you double click on click once more on this, it will just collapse sideways. So you have your um, implementation code and you have corresponding test code here. You can close this stuff if you want. So this is the unit test case. The reason that I'm opening it side by side is simply because I want these functions to be called here, and I'm not going to remember what's happening, like what are the functions. So let me just import um, news. I think okay. You also need to know the directory structure. So it is parallel to news. So because you need to sort of import from news. Let us see if it works. Uh, test. So parallelly you write unit test cases. That's the idea. So okay, we will write it. So yeah, this is one of the things that you need to do. So I'll just finish the logging part and then come back to this. Okay. So now we have written code for logging. We are trying to understand this. So let not digress from here. We'll write come back here. Okay. So let us try to simulate that. So we were trying to simulate, that is why we were writing test code for that. So right now on your like system, if you just want to simulate it, probably you want to set say URL to some www some non exists.com, something like that. I don't know whether it's present or not. I'll just add some characters here so that probably there is some that code does not exist. Never know. So when you have a URL and URL side by side, this variable gets overwritten. So you don't have to comment this at this point. So let us try to run and see what happens. Okay, so you can see that it says that invalid URL not supplied and so on. So this is an exception. Okay, so where am I getting this exception from? Is from this place, right? So this has halted the entire code. So you need to put it into the exception block and put it. Let us just put this part um, in the exception. Exception. Okay, you'll need to capture the right exceptions, but this is like this captures all the exceptions. Okay, so as E is just an exception, and then you can you'll just do thing, skip, yeah, convert this string into object into string, and then you can print it. Okay. So now let us look at what happens here. Okay, this is not there. And this error, unbound local error, is coming when at this point of time we have uh, defined this variable, but once you come out of this, this is not aware. This line is not aware of that. So let us try to put all of this in this block. So let me move this. So you can see that even if you have access to chat GPT and all these things, it takes time to stitch the code. So uh, of course your time to code reduces drastically, but these things where we are trying to modify the code in such a way that it fits into our um, requirements, it still takes time. So this is why our developer jobs are people who are want to development come to development. They don't have to get demotivated saying that okay, developer jobs are getting away and things like that. So these things you cannot do using ChatGPT. Of course, the time probably will reduce it to like 50% or 60%, probably even 80% in some cases. But yeah, it doesn't happen. Okay, what's happening here? Okay, news 47. Okay, I have here. Let me take this variable and put it outside here. News. Okay, so you can see that the exception is caught here, and it says that. So let me go back here and okay. So here it is not even giving the status code because it is not a response object because this URL itself is invalid URL. So that is why I'm getting it. So in order to simulate this, you'll have to get some URL and then get some other status code. So which we cannot do because we do not know the behavior of non you know um, non 200 errors, right? Because we need to read the document and come back and simulate it. So let us try to take this error which we have simulated and put it to fatal. Same thing. So this code still is valid. So you don't have to remove this code. So this is where instead of print, I can put here saying that, in fact, I can catch this error. So that was what sort of error. So you can do something like this exception. Instead of this exception, you can write the exception that we had got, say this invalid URL or whatever the exception it got. So right place is to do it like this. So try to cache the specific exception first, and then go to the like the larger patch. So this is the common patch. So yeah, takes time to write everything. So I'm just trying to demonstrate this logging pattern. Could not get response. Okay, probably okay response. And run this. Okay. Let me comment all of this so that okay, let's be there. So now you can see that this all of them are also get you can actually disable this. So this stuff which are coming from here are getting printed on monitor as well and to the log file as well. Let us look at the log file. Where is the log file? There. Have I defined the log file? There is no log file. Let me just um, go here. Where was that? What's that? On init log file. Go to documentation. Pick the code. Uh, okay, here logging to a file. You can take this line. There is a configuration for this, and you can put it back to your code. And this is like basic config, and you're saying that use this log file. Let's run this again and see. You can see that there is a file called as example.log which got generated. So we specified that. And you can also see that in IDE, these things got sort of highlighted, like debug info, they're in different colors and so on. So let's go back here. Okay, probably fatal is not supported, or don't let us put error. Let's see what is that. Put not put okay response. Set even coming. Yeah, I think fatal is, I don't know whether it's there or not. We can check that later, but we are trying to understand different levels. Okay, there is we put it as error now. So now it is printing in the log file. So let us put log. Say at this point of time, I want to say logging and info, just info, and I can say getting from API. So let us run this and look at log file. You can see that its info is printed here. So you can also enable just, so these are like various levels. So you can also disable info logs. So you can say uh, how to disable, you can look at how to disable as well. Let us look at how to disable. Python login disable info. Log or disable. So complete logging is disabled. Disable info. You can set the log level. So that's called as log level. I think it's log or log level variable. You see that even it's coming from Gemini. You can do this as well. So this is actually taking from some place, which is I think ChatGPT is also taking from the similar place. Logging level. So yeah, let's take this. So this is one of the parameters of the configuration. You can go here, and sometimes when you have larger software, right, which produces a lot of logs, you don't it okay, yeah, it's already set to debug. You can set it to, I think, error. Okay, let me try to run this. Let me remove all these lines. Um, Go back here. Run. Let us look at example.log. You can see that there is no info logs here because we have set it to error. So it's like a debug, info, warning, error. There is a severity levels, right? So we have disabled severity levels just by generally this log statement, the line number 7, will be put into some file which we call a settings file. You can create a settings file here. For example, settings.py, and move such things. These are common for all the places, right? So you can take this and put it here. Okay. So this is how you can sort of move the code around and you know, refactor it. So that is about logging and various levels. And remember that this is one of the important concepts generally overlooked, because if you enable all the logs, your logs become big, and if there is memory constraint, it will also consume the disk space, and then your other processes won't run. It may get slowed down, or it will crash because there is no space to run. So enable logs, which are just necessary for debugging. Now there are also technologies where you can watch these logs. So it watches these log files and pushes it to somewhere else. So that is where your the term observability comes. So there are on top of these logs, so whichever we looked at now, say fatal logs and these logs. So you can see that it's not printing anymore, right? So it is printing into the log files. So these logs which we are printing, it watches the log file, and these logs are captured. And so imagine you have a server. This is your production server, and there is some observability um, software or server which is running separately. So basically, you send these logs over the network, yeah, or if it's in the same server, you can watch these logs. So send these log files here. In fact, you are streaming those logs as it comes, because it's sort of a real time. And this guy who is observing these logs looks for specific errors. If this is error, he will highlight that and put some sort of a threshold. You can program it saying that, okay, if you get this pattern, then send a mail or raise an alert, send a notification or something like that. So one of them you might have heard called as Splunk, so which helps us to do this. So you stream these logs to Splunk, and you can configure Splunk into different this one. So one more thing I wanted to show, I forgot to show, is timestamps. So in this particular example, you can also enable timestamps here, because now we know the sequence, but we do not know when it happened. So let us look at that example. Uh, Go here, and I think timestamps. Add timestamp. You can see that you can add it like this. So this is also part of your basic configuration. Take this, yeah, and put it here. Okay. So this is the format. You can change the format to according to your needs. Let me run it, and let us look at the log file now. Oh, very good. did print. Okay, we have disabled the probably. Let us. Sometimes things doesn't work, so you need to sort of debug what's happening. Uh, the debug and logging.info. Let me change it back to info. Let's see. And format. It's not coming. Basic configuration log format. Okay, I need to specify the format as well because this could be in any order. This page. Look at this now. Yeah, you can see that we are getting the timestamps here. So there are two things you don't have to remember, but so for example, I didn't remember that, but I'm able to debug because I know what these configurations look like, and there could be some configuration missing. So I found out that this format, this is required to take this as an argument. Okay. So more you code, you get this sort of, in fact, you can search internet saying that, okay, timestamp is not getting printed and you'll get some answer. But you should remember that logging is a facility where you get these sort of timestamps and this. In fact, you can also print the line numbers and you can also print the module name as well. So you can even look at that here. So, yeah, timestamp, add module name. So I think package name, model name. Yeah, you can add this. So you can experiment with these things. And yeah, you can keep working on this logging. And once you set it, it helps everybody. So imagine that in the real time, these small lines are getting streamed to your observability, and then something happens, and if it looks at error or critical or fatal, I think fatal is not supported anymore. I'm not sure, but you can look it up. So and then it sends you a notification. So that is one of the powers of logging it. The because you have this format, Splunk or some guy who is doing the observability is able to parse it properly. If it was print statements, probably you wouldn't. It is not scalable, right? And you cannot have the proper order. Imagine a lot of processes from different servers you are trying to aggregate logs, it becomes complicated. So use logging library and do not use prints. That's about logging and observability and some tips about coding, how to move code, how to add defensive code and stuff like this. Okay, we will learn these things more in coming lessons as we move to finishing up the project. Actually, writing code is not a big thing, right? Now you understood that writing code is not the challenge. It's about organizing the data structure and the data flow in our mind and putting it here and moving the code around and adding what thinking what could go wrong and adding code according to that. So um, this is language agnostic. That means any language, it is not related to language at all. So this thought process is the main thing that differentiate just the developing language and the developers and the engineers, right? So first thing is the mental model, and next is writing the code. Writing code is now become easy, but it is it saves time. It is, but it doesn't take out the fact that there needs to be some manual effort put into managing this code, moving things around. So we haven't added a feature here. So imagine we are adding new features and there are bugs and there are some problems and debugging and code grows. Uh, Code keeps growing all along. So which is equivalent to you are expanding or you are modifying your sort of moving your thought process or the structure that you have in your mind, mental model is moving around. So since you have the context and you know how things are organized, you can do it easily. So that is the most important thing in coding. So writing code is quite simple, as we saw. We can get it on Stack Overflow or on ChatGPT. Okay, so that is about logging. Thanks for staying. We shot over 10 minutes. Yeah, that's it. If you have any questions, please feel free.